Good morning, everybody. My name is Mr. Dominic, physics teacher. Today we'll be looking at elasticity. And it's an SS1 topic actually, so this is an SS1 class. From the word elastic, what do we understand by the word elastic? An elastic material is any material that can expand. And when it expands, when you leave it, what happens? It comes back to its original shape. That is an elastic material. We won't talk about elasticity. Elasticity itself is the ability of that material to be able to expand and come back to its original shape after it has been distorted. When I say distorted, D-S-I-T-O-R-T-E-D. Distorted means for something to be disturbed. Like for example now, this is a spring, it's an elastic material. A rubber band is an elastic material. A string is an elastic material. A spring is an elastic material. Now, for this string that I'm holding, if I draw it out like this, automatically I've distorted the string. And when I leave the string, what happens? It comes back to its original shape. So that is the meaning of distortion. So any material that when you expand, it comes back to its original shape is called an elastic material. And elasticity is the process itself of that material to be able to regain its original form after it has been stretched or disturbed. The person that talks about elasticity in detail will refer to him as Hooke, and he propounded what we call the Hooke's law. Hooke's law is the relationship between the expansion or the elasticity of a material with respect to the force applied on the material or the load applied on the material. Now, what does Hooke say? Hooke stated that the force applied on an elastic material is directly proportional to its extension. I'll say it again. The force or the load applied on a material is directly proportional to its extension. What is that trying to say? Now, what Hooke is trying to say is this. When you put, for example, a marker, if you're able to hang a marker on this string, it will come down. But the level at which this material will expand is not the same as if when you hang a stone or a heavier material on this same string. When you hang a heavier material on this same string, the string will expand more. And the ability for the string to expand is what we call elastic. I'll say it again. The ability for the string to be able to expand is what we call elastic. When the string is pressed together, we call it compression. I'll say it again. When the string is pressed together, we call it compression. But when the string expands, we call it expansion or elasticity. Any of them. Now, what Hooke is trying to tell us is this. When you hang a marker on this string, definitely it will expand. But when you hang something like a hammer on this string, definitely we know that a hammer is heavier than a marker. This marker will extend the string, but it will not expand it as much as the way a hammer will expand the string. So Hooke is telling us that the expansion of a string is directly proportional to the load. That's to tell you that the more the load, the more the expansion. When we say directly proportional, it means the more one of the quantity, the more the other quantity. But when we say inversely proportional, it means the more one of the quantity, the lesser one of the quantity. But what Hooke is telling us is this: the more the load, the more the expansion. Good. So let's continue. Now, from Hooke's law tells us that the force or the load is directly proportional to the expansion. This sign means direct proportional. When we say inversely proportional, it will look like this. It will look like this. F is inversely proportional to E. This is what we mean by inversely proportional. And when you see this in physics, it means that when this is increasing, this is reducing. I'll say it again. When you see this in physics, it means when this is increasing, this is reducing. And we call it inversely proportional. But for this, it means that when this is increasing, this also is increasing. So, according to Hooke, he told us that the more the force or the load, the more the expansion. Now, when we take away a sign of proportionality in physics or mathematics, we must introduce what we call a constant. So it will be F is equal to, now we have taken away our sign of proportionality. It's no more a sign of proportionality, but equal to. And whenever you put equal to, you must put a constant, which is K. That constant can be anything at all. It can be G, it can be A, it can be K, depending on what you are dealing with. So, for that of elasticity, our constant here is K. F is equal to KE. this is the formula used in calculating the expansion of a string with respect to the force or the load applied. I'll say it again. This is the formula used in calculating the extension of a string with respect to the force or load applied. F is our force. Sometimes it can be given as load. And what is the SI unit of force? The SI unit of force is what? It's Newton. I'll say it again. The SI unit of force is what? It's Newton. And so is the SI unit of weight. Sometimes when you're solving questions under this topic, they don't give you the force or the weight. What they actually give you is the mass, which is given in kilogram. Sometimes when you're calculating questions under this, they don't give you the force or the weight. What they give you is the mass, which is given in kilogram. So whenever you're given the mass, what you do is that you multiply the mass by 10. For example now, if I'm given 20 kg as my mass, and I want to change it to weight or force, what I just need to do is to multiply this by what? By 10. And this will give me what? 200 Newton. This 200 Newton is the same thing as my weight or my force. What does this 10 stand for? This is our acceleration due to gravity. This 10 stands for our acceleration due to gravity. And why do we multiply by 10? Because the weight or the force of a body always acts how? Downward. And whenever a body is on the Earth's surface, it's expected that the force of gravity must act on it. And we know that the force of gravity is given as what? Approximately what? 10 or 9.8 meters per second square. So let's continue. Our K here is what we call our elastic constant. Our elastic constant. And it's the SI unit is what? Newton per meters. Newton per meters is our SI unit. While our E here is our elasticity. Our elasticity is our E. And what is the SI unit? The SI unit of our elasticity is what? Is meters. The SI unit of our elasticity is what? Is meters. Due to the limitation of time, I will not be able to solve any exercise, but I've given you the formula and you can pick up any exercise. Okay, let's solve just one exercise so that we can drive our point and give us a better understanding of what we have been talking about. Very good. Now, I'll write it. Example, a force of 0.8 Newton stretches an elastic spring by 2 centimeters. Full stop. Find the elastic constant of the spring. Find the elastic constant of the spring. This is a very simple question. Now, normally I told you that whenever you are attacking a question in physics, for you to have an idea of where you're going, of what is given to you and what is not given to you, it is advised that first you collect your data. Very, very important. You collect your data. Now, collecting our data. Our force is what? 0.8 Newton. Another important thing to look at is the SI unit. I told you earlier that the SI unit of force is what? Is Newton. And here, the force is given to us in Newton. The SI unit was not tampered with. So we are okay with that. Next, we go ahead, stretch an elastic spring by what? 2 centimeters. This stretch is our what? Elasticity. That is our elasticity. So our E is equal to what? 2 centimeters. But another thing we have to look at, if you allow this 2 centimeters to be like this, automatically you have failed the question. Why? Because earlier I told us that the SI unit of elasticity is what? Is meters. So we cannot leave it in centimeter. We must convert this centimeter to what? To meter. And for us to convert centimeter to meter, what do? We divide it by what? 100. We divide our centimeter by what? 100. This will give us what? 0.02 meters. Now we've gotten our answers in meters. We can continue from here. And the last thing here is our what? is our elastic constant K, which is what we are looking for. So, according to Hooke's law, F is equal to what? Ke. And we're looking for K. So what do we need to do? We need to make K subject of formula. How do we make K subject of formula? By dividing both sides by what? By E. So that E will cancel what? E. And from here, we have it now to be K is equal to what? F over what? E. Very good. So let's continue. What is our F? Our F is what? 0.8. And what is our E? Our E is what? 0.02. Now, for us to solve this, I'm going to teach you an easy method to solve it, whereby you don't need to stress yourself. Now, move your point one time. This will give you 8 times the raised to the power of minus 1. Over, move your point 2 times. This will give you 2 times the raised to the power of what? Minus 2. Using our law of indices. Using our law of indices. What is 8 divided by 2? 8 divided by 2 will give us what? 4. Multiply by, whenever you see law of indices, division means what? Subtraction. Division means subtraction. So what are we going to have here? We're going to have 10 raised to the power of minus 1 minus 2. Minus 1 minus, this minus is this minus here. This negative here is this division. Why this negative here is what we have here. And whenever you have negative outside a bracket, what do? You multiply. So minus times minus will give you what? Plus. So this, that question now will now be 4 multiplied by 10 raised to the power of minus 1 plus 2. I believe it's understood. Because minus multiplied by minus, bracket automatically means multiplication. Minus multiplied by minus will give us what? Positive. And here now, so we're going to have 4 multiplied by 10 raised to the power of what? Minus plus, you subtract. Remember, minus plus, you subtract. But the answer the sign that will follow your answer is the sign following the big number. I'll say it again. Minus plus, you subtract. But the sign following your answer will be the sign following the big number. So 2 minus 1, what will it give us? 1. So we're going to have 1 here. But that's not all. We have to look at the big number between 2 and 1. Which one is the biggest number there? 2 is the biggest number. What is the sign following 2? It's positive. So our answer will be carrying what? A positive power. Is that okay? Our answer will be carrying a positive power. So I can write plus here, but we also know that whenever it's positive, we can just leave it like that. It's not that important to write it, but if it's negative, you must write it as a matter of necessity. And what is our SI unit? Our SI unit is what? Newton per meter. So that is our elastic constant. Good. Let's continue. The last thing before we wrap up the class. Whenever we're talking about expansivity, there are other things we need to take note of. Because this spring cannot just continue expanding. They will get to a time that whenever you put a load on it that it cannot forbear again, what will happen? It will stop. It will expand, but it will not contract back. It will expand, but not what? Contract back. Because you have given it a load that it cannot handle. Now, when we're talking about elasticity, there are 3 things we always look at. Number 1, we call it the elastic limit. Number 2, we call it the yielding point. And number 3, we call it the breaking point. I'll repeat it again. Number 1 is the elastic limit. So let me write it. Number 1 is the elastic limit. Number 2 is the yielding point. And number 3 is the breaking point. Now, what is the elastic limit? The elastic limit is that particular axis. Actually, it's a graph. It's a graph. Let me quickly draw it so that it will give us a better understanding of what I'm talking about. This is how the graph of elasticity always looks like. Now, as you can see here, this is load against extension. Now, here it tells you that the more the load, the more it expands. Here is what we call the elastic limit. At this particular point, whenever I remove the load, the spring will do what? Will come back to its normal size. That is why it is called elastic limit. So the elastic limit of a spring is a particular place on the spring graph that if you put a load, it will be able to come back to its normal size. But there's a place that will, after the elastic limit, this place we call it the yielding point. The yielding point, when you put a load now, it will get to a particular time that spring will expand, but it will not come back to its original size. Why? Because you have put it so much load. Yes, it expands, but if you leave it now, it will not come back to the original size. We are familiar with that with the rubber ring. There are sometimes that when we stretch a rubber ring, it will open and it will not come back to its original size. That is what we call the yielding point. Now the breaking point is this place. This is what we call the breaking point. The breaking point is a point on the elastic graph that when you continue putting load on that rubber ring, what happens? It snaps. When I say snap, it's cut into two. We are familiar with that. Whenever you try expanding the rubber, expand it to a particular length, it will cut off. That place where that rubber ring cut off is what we call the breaking point. At that particular point, the material automatically is destroyed. Like this spring now, if I continue putting a load on it, at a particular time, it becomes like a thread. And if I continue, it will get to a point that it will break off. When it breaks up, we call it the breaking point. I'll take it again. So when we're talking about a spring, there are three things we look at. Number one is the what? Elastic limit. Number two is the what? The yielding point. And number three is the what? Is the breaking point. So we're going to stop here for today. In our next class. Okay. Before I go, let me leave you with a little exercise to do. A little exercise, just a little one. Homework. A mass of 20 kg stretches a spring by x meters. Assuming the elastic limit, so the elastic constant is 40 Newton per meters. First off, find x. It's a very easy question. Just that you need to make x. Now you should know what your x is, and then you should make it yourself just a formula. From there, you should get your answer. So have a nice day and take care of yourself. Thank you.